The 8 mechanical properties of materials are: number 1 is stiffness. Stiffness. Stiffness is, as we have discussed before, the Hooke's law or stress strain diagram. We have a proportional limit, and then this is the ultimate point, and then the elastic. So up to this we have this elastic limit, which maintains sort of y equals mx type of relationship, or sigma equals e epsilon. This e, the modulus of elasticity, is the measure of for the stiffness. So basically it's defined by the modulus of elasticity. The higher the modulus of elasticity, the higher the stiffness of a material. Number 2 is the strength. Now strength is not just one single parameter. As we have discussed, that this point is a yield point, and then we have yield strength, and then this is an ultimate point. This one is a fracture point. So yield strength of material, that property, or the strength of material, strength property, is defined by yield strength, ultimate strength, or fracture strength. And then the third property of material is elasticity. Basically the ability of material to go under deformation without leaving that yield point. So how much it is elastic, that is defined by this straight line area. It could be defined by the modulus of elasticity E, like the stiffness, and this one is mostly defined by yield or ultimate strength or fracture strength, like that. This one somewhat we can relate to E, the measure of elasticity. And then the number 4 is the ductility, is the ability to take tensile load. The ability to take tensile load is ductility. How much it can take. Now, this is not just the ability to take the tensile, it also how much plastic deformation it can take under. So this is the area, plastic deformation, meaning that once it go past this yield point, it will never come back to its original position. So the elastic limit is gone, so the material will be under plastic deformation. So the ductility property is basically the ability of material to go under a plastic deformation under tensile load. Number 5 is the brittleness. This is the opposite of ductility. Brittleness is the opposite of ductility. Brittle material stress strain curve look like this, and it just break right here. So it doesn't go any plastic deformation, it has only elastic portion, elastic limit. There is no plastic deformation. Glass, for example, concrete, those are brittle, the opposite to ductility. They don't have any ductile property at all. The number 6 is the malleability, which is similar to ductility but under compressive load. So this one is under compressive load. So how much a material can go under plastic deformation under compressive load, and this one is under ductility, is under tensile load. Like that. Number 7 is the toughness. Toughness is defined by the impact, how much a material can take with respect to impact or shock load. So the ability of material to take impact or shock load. You can think of steel can take a lot of impact. However, glass, concrete, bitter material cannot really take any shock load at all. So basically, toughness can also be defined by the area under the curve of that plastic region, so amount of plastic deformation. So if the material is more tough, the area under the curve under the plastic deformation stress strain curve will be higher. Resilience, the last mechanical property, you can imagine something like foam, which can take a lot of high impact loads without going beyond the yield point of the material. So you can beat up, it will keep taking loads without going passing over the yield point. So the ability to take high impact load without going over the elastic limit. So high impact load without going yield point. Now this one is the toughness is more related to the plastic deformation, resilience more related to the elastic. Toughness actually a complex property, but resilience more specifically within the elastic limit. Toughness on the other hand is more plastic deformation. So that's the 8 properties of material.